How much pure antifreeze must be added to 8 gallons of 10% antifreeze to create a 50% antifreeze solution? All right, so this is like one of those classic mixture problems. You're mixing two things together and creating a mix. Right? So the two things that I'm mixing are pure antifreeze to a 10% antifreeze. So, and pure, that's 100%, right? That's what they mean by pure. Okay, so 10% solution, and then we have a mix of the two, the pure and the 10% solution. So this is my standard approach for any kind of mixture problem, is to make a table like this. And then, so those are the entries, the two things you're mixing together, and then the mix, those are the rows. And then for the columns, I put percent antifreeze, or percent whatever it is that you're mixing. And then the amount of the solution. And then the amount of antifreeze. So if you have, then we just fill in all the stuff we know. So how much pure antifreeze? That's the question. So how much pure antifreeze would go here? So I'm going to call that an X because that's what they asked us for. Must be added to 8 gallons of 10% antifreeze. So my 10% solution, I'll put a 0.1 instead of 10%. The amount of that solution I have is 8 gallons. So if you have 8 gallons, that's 10% antifreeze. That means it's 10% antifreeze, 90% water, right? Okay, so if it's 10% antifreeze, 90% water, how many gallons of antifreeze is in that solution? Of pure antifreeze is in that 10% mixture. 10% of the whole 8 gallons is antifreeze. 0.8, yeah. 10% of the total is pure antifreeze. So it's 0.8 gallons pure antifreeze, 7.2 gallons of water, right? So this is 0.8, right? And I get that by multiplying the 10% times the 8. 0.8 gallons is pure antifreeze. Now my pure antifreeze, its percentage is 1 for 100%, which means that because all of it is antifreeze, I have X gallons of it. That's X gallons of pure antifreeze. And you can also think of it as 1 times X. X. All right, and now my mixture, it's supposed to be 50%, so I'm going to put a 0.5 there. And I'm adding pure antifreeze to the 10% solution, X gallons of pure to 8 gallons of the 10%. This is 8 plus X. And then I have two ways of figuring out what goes in this last box, right? I could either add up how much pure antifreeze I have in the first mixture to how much pure antifreeze I have in the 10% solution, which would be X plus 0.8. Or I could multiply 50% times the amount of solution I have, because half of it is pure antifreeze. So I could do 0.5 times 8 plus X. Two ways of calculating the exact same number, which means they have to be equal. So that's going to be my equation. X plus 0.8 is equal to 0.5 times 8 plus X. And then we just solve this equation. I'll distribute my 0.5, so I have 4 plus 0.5x equals x plus 0.8. I'm going to subtract a half x from both sides, so I'm going to have half x. I'm going to subtract 0.8 from both sides, so I get 3.2. And then I divide both sides by 0.5, and I get x is 6.4. Mm-hmm. So that's tricky because there's so much information to put in this table. There are 9 entries, right? So sometimes they give you different ones. So like you have to sort of comb through the question for the stuff that they told you and then put in the stuff that you don't know as X or Y or products or sums of what you do know. Okay, the other mixture problem. This time we're mixing peanuts and walnuts. So I start by making a little, putting those as my entries, the rows in the table, peanuts, walnuts, and a mix. All right, and then the other stuff that they tell me about these things are price per pound. The question is how much of each kind of nut, so I'll put in number of pounds for how much. And then what I can figure out is total cost. If you know the price per pound and the number of pounds, you can get total price by multiplying the two. Okay, so let's put in the stuff that we know. Peanuts are $2.49, walnuts are $3.89 per pound, and my mixture is supposed to be $2.98 per pound. And then the number of pounds, they did not tell me that's the question, right? How much of each kind of nut is put into the mixture? So let's have the number of pounds of peanuts be X. We're making 100 total pounds of the mixture. So how many pounds of walnuts are there going to be? 100 minus X. 100 pounds total. X pounds of them are peanuts, which means 100 minus X. All the rest of the pounds are walnuts. You could also call that Y and solve a system of equations. You called it Y though? Okay, so does anybody care which way we do it? It should come out the same. So I'll call it Y. Oops. So if we call this Y, this is 100. And then my total price is the price per pound times the number of pounds. So this is going to be 249X, 389Y, and 298 times 100 is 298. All right, so now I got to try, because I used 2 unknowns here, an X and a Y, I have to write 2 equations, right? If I had just used an X, I would only need 1 equation. 2 unknowns, 2 equations. So one equation I know is that X plus Y has to give me 100. The number of pounds of peanuts plus the number of pounds of walnuts has to add up to 100. And then another equation is that the cost of the peanuts plus the cost of the walnuts has to add up to my total cost. So 249X plus 389Y has to equal $298. So now I have 2 equations and 2 unknowns, and you can solve that either by substitution or elimination. I would use substitution because this first equation is easy to solve for Y or X. So Y is 100 minus X. So now, instead of putting, you could do it the other way, yep. X equals 100 minus Y, yep. That should give you the same answer. So instead of Y right here, I'm going to put a 100 minus X because they are equal. They're the same. So I'm going to make a substitution. So I have 249X plus 389 times 100 minus X equals 298. And then we just got to solve this equation for X. So I'll distribute my 389. That 298 represents the total price of the mixture, which is $2.98 per pound, and there's 100 pounds. Yeah. So I multiplied 298 times 100 to give me 298. Okay. Yeah. So in general, in these mixture problems, you multiply across, right? You multiply to go across, and you add to go down, except for the first column, right? X plus Y is 100. 249x plus 389y equals 298. So you can add. Um, it's going to depend on the problem. It's going to depend on the problem. Sometimes all you use is the information in this last column. Sometimes that will be given and you use the stuff from the middle to write your equation. Yeah, it depends on what's given. All right, so let's see, I need a calculator. Oops. Oh, I missed an X, there we go. All right, so 249 minus 389 is negative 1.4x. And then I'm going to take 298 and subtract 389. Oops, I divided. Negative 91. So x is 65. All right, so that means that x represented the number of pounds of peanuts. So it's 65 pounds peanuts. And how many pounds of walnuts? 35, because I'm making a total of a 100-pound mixture. So be sure when you're doing word problems like this that you actually write the answer to the question. Don't, circle that and be done, because that's not all that they asked you. So make sure you go back and reread the question and make sure you answered it. All right, so according to the American Bureau of Labor Statistics, you're going to devote 37 years to sleeping and watching TV. So in total, 37 years will be spent sleeping and watching TV. So we've got two things. We've got sleeping. We've got TV watching, and we've got a total, the two together. Okay. You'll spend 1 more year sleeping and 3 times the number of years you spend watching TV. Oh, I might not need a table to do this. Yeah, let's not do that. Okay. So first, let's narrow in on the question. How many years will you spend on each of these activities, sleeping and watching TV? So let's let X be the number of years sleeping and Y be the number of years TV watching. Okay, so together, that's 37 years. So I know X plus Y is 37. And you're going to spend 1 year more sleeping than 3 times the number of years you spent watching TV. So if you take the number of years you spend watching TV and you triple it, that's what 3 times means. So that's 3y, right? 3y. 1 1 year more sleeping plus one. 1 more year. Okay. So you want to spend 1 year more. I just want to make sure we wrote this equation right because it's easy to put the 1 in the wrong spot. Spend 1 more year sleeping than 3 times the number of years you spend watching TV. Okay, so 1 year more than that. Yeah, I'm not sure that 1 is in the right place. So we've got 3y and we've got x, right? So triple the number of years you spend watching TV, and somehow that's related to the number of years you spend sleeping, right? And it says you're going to spend, and if I put an equal between them, I have to sort of balance this equation. So I have to figure out where to put the 1 to make it balanced, to make those two things equal. And right now it says you spend 1 year more sleeping than 3 times the number of years you spend watching TV. It is confusing. You got to really think about it. It's like a language thing rather than a math thing. 1 year more sleeping than 3 times the number of years you spend watching TV. Yeah, it definitely matters. Uh-huh. One year more sleeping. Yeah. Yeah. So I think the plus 1 does go here. Right, because right now, if I don't have the 1 there, right? Oh, you can't see that I'm covering it. If I don't have the 1 there, then right now the number of years sleeping is 1 too big because you spend 1 more than 3 times the number of years watching TV. So you got to add 1 to TV watching to make it equal. So I think that's right. I think we had it right the first time. All right. So now let's see. I should solve this thing for anything I want, either x or y. Solve for y. 37 minus x. So I replace this y with a 37 minus x. And let's see, 3 times 37 is 111 minus 3x. So move the 3x over and I get 4x, and this is 112. And I get x is 28. And 28 was number of years sleeping. X is 28. So it's 28 years sleeping, which means how many years are spent watching TV? 9. Okay, so Vani recently set out to ride her bike on a 30-mile route, but she got a flat tire toward the end of the route. Having forgotten her tire patch kit, she had to walk the bike the rest of the way, and her average speed was 25 miles per hour when biking, but only 5 miles per hour when walking. She took a total of 1 hour and 24 minutes. How long was she biking before getting the flat tire? Okay, so I read this as a mixture problem. This is a mixture of biking and walking. So I'm going to make a little table, biking, walking, and instead of a mixture, I'm going to put total here. Because you can't really mix them up, like you do them separately, but you have a total of the two together. All right, so let's see. The other stuff they told me about her biking and her walking are the rate and the time spent doing it, right? 1 hour and 24 minutes, and the distance traveled, right? And we have that formula, rate times time equals distance, RT equals D. So that will help me fill in this whole table. So let's see, biking, her rate was 25 miles per hour, and walking it was 5. And you can't have a biking and walking, you can't do the two together, right? So this block doesn't even make sense in this case. I guess you could come up with an average, but it's not going to help us. All right, and then so for time, that's the question, right? How long was she biking before getting the flat tire? So we'll call X the amount of time she spent biking. And we know the total time was 1 hour, 24 minutes. So if I wanted to put that in as a decimal, right, 24 minutes out of 60 minutes in an hour, right, is 0.4 of an hour. So this is 1.4 hours. So that's one place where people make mistakes on this problem, is they write 1.24. You could do it all in minutes. Yep, that'd be fine. Yes, the only problem with that is that your rates are given in miles per hour. So you would have to change them to miles per minute if you wanted to do everything in minutes. Yep. Okay, so then the time spent walking is the total time minus the time spent biking. And you could call that y if you wanted and write two equations. All right, and then distance is rate times time. So this would be 25x, and this would be 5 times 1.4 minus x. And what's the total distance? 30 miles. So then I can write my equation, the distance biking plus the distance walking is a total of 30 miles. So 25x plus 5 times 1.4 minus x is 30. Okay, so 30 minus 7 is 23. That's 20x. So x is 1.15, and x represented the amount of time we spent biking. And that was measured in hours. Biking for 1.15 hours. Sure. Yeah, so the 1 hour, 24 minutes, right? I just want this to be in straight hours, right? Instead of hours and minutes. So I would say, well, 24 minutes is how much of an hour? So I could set up a proportion like part to whole equals part to whole. So I could do 24 is to 60, right? Part to whole, as what is to 100, right? If I wanted to figure out what percentage of an hour it is. And then I would solve this thing and I would get x equals 40% of an hour, or 0.4. Right? So this is 1 hour plus 0.4 hours, 1.4 hours. All right, a colony of 1,000 bacteria is growing exponentially at a continuous rate of 9% per day. How long will it take the number of bacteria to double? All right, so continuous rate should immediately tell you what formula to use. And it's this one where the amount that you have is equal to your original amount times e to the k t. So that word continuous means it's the formula with the e in it. So that's the key word in that to tell you what formula to use, continuous rate. Okay, and k is the 9% or 0.09. And 1,000, that's your original amount, a sub 0. So that little 0, that's the subscript, you can read that as representing time 0, or I think of it as an O for original amount, right? So you can think of it either way to help you remember what it is. All right, so we have 1,000 bacteria growing at a continuous rate of 9%. How long will it take for the bacteria to double? So if they're asking us a question about how long it will take, which variable am I going to be solving for? T. Okay, so I have to put something over here on the left for A of t. 2,000, yeah, because you're starting with 1,000 and we want to know how long until it doubles. Double 1,000 is 2,000. And then we want to solve this equation for t. So I divide out 1,000. First thing you do is isolate the exponential. So we get 2 is equal to e to the 0.09 t. And then you have a variable in the exponent. What do we use? What tool do we use? Take the ln of both sides. So the ln of 2 is equal to the ln of e to 0.09 t. So that is the cardinal rule, right? If you do whatever you do, you just have to do it to both sides. So I'm going to take the log of both sides. And then the reason I do that is because it allows me to take this exponent and put it down in front. So this becomes 0.09 t times the ln of e equals the ln of 2. But what is the ln of e? 1. It's just a 1. So this says the ln of 2 is equal to 0.09 t times 1, which is just 0.09 t. And then divide out the 0.09. So ln of 2 divided by 0.09, 7.7. And this was being measured in days. Okay, so here I've got a variable in the exponent. The exponential is already isolated, so to get that variable down, I take the log of both sides. And that allows me to take my 2x and bring it down. So I have 2x times the ln of 3 equals the ln of 80. And then to isolate the x, I can divide by 2 ln 3. Because then those will cancel and those will cancel. And I get x is the ln of 80 divided by 2 ln 3. And I would give that as my exact answer. And often, I mean, and one of the great things about just being given an equation to solve is that you can check it, right? So I could do ln of 80 divided by 2 ln 3, and I get about 2.4, right? So for my own checking purposes, I can say, okay, that's about 2.4. So 3 to the 2x should give me 80. So 3 raised to the 2 times 2.4, right? Because 2.4 is x. This should give me close to 80, right? Because I'm not using the exact answer, but 2.4 is close to the exact answer. So that is wrong. What happened? Uh-huh. Aha, okay. So I think I did an order of operations mistake when I did ln 80 divided by 2 ln 3. I need to put parentheses around the whole denominator, otherwise it will divide by 2 and then take the result and divide by ln 3, which I think should be the same, but yeah, there it is, 1.99. Yeah, but you won't come out with an exact answer, right? So if you wanted to, yeah, so you could do 2x times, and instead of writing ln 3, you could put in an approximate value that is equal to ln 3, so like 1.0986. And then you could put an approximate value for ln 80, 4.382, right? And then solve for x. But what you're going to get is this 1.994, which is an approximate value, right? And this is the answer that you'd be looking for on a test. But this is a good way to sort of check your work, you know, do it both ways, make sure it comes out the same, plug the value in. So now if I do 3 to the 2 times 1.994, this should be approximately 80, and it's really close, right? It's not exact because I rounded this number. The exact value is ln 80 over 2 ln 3. Okay, so I have x plus the square root of x minus 3 equals 9. All right, so we got to remember do and undo, right? So what is being done to x and how do you undo it? Okay, so that big square root is being done to the x. How do you undo square rooting? Squaring. Yeah, you have to do the opposite thing to undo it. So I want to square to get rid of the square root. But what should I do first? Move the x to the other side, yeah. So I want to isolate the square root before I undo that. So now that the square root is all by itself, I can square it. And I'll square the other side also, because you can, whatever you do to one side, you have to do it to the other. So when you square a square root, those two things just cancel, right? They just undo each other. So I'm left with an x minus 3. And then 9 minus x squared. I have a little, it's not a rhyme at all. I don't know why it has stuck in my head since 8th grade, but it's square the first. So you square the first one, square the first, square the last one, the negative x is square, you get it squared. Take the product, 9 times negative x is negative 9x, and double it, negative 18x. Square the first, square the last, take the product and double it. Yeah, and if you can't remember the little saying, just remember that this means 9 minus x times 9 minus x, and FOIL it. And you get 81 minus 18x plus x squared, and now you have a quadratic. So I have x squared, subtract x from both sides, add minus 19x, add 3 to both sides, plus 84 equals 0. And then you can either try to factor it or use the quadratic formula. All right, so yeah, let's finish this. 84, does it have any factors that would add to 19? So 84 divided by 7 and 12 is 19. Okay, good. So I'm going to have to both be negative. X minus 12, x minus 7. It's 12 times 7 gives me the positive 84, and then you negative 7x and negative 12x make negative 19x. Okay, so that means x equals 7 or 12, right? Seemingly two solutions. However, when you go back to your original equation and check your solution, which you should always do, only one of them is actually true. So let's see, if I put in a 7, so I have 7 plus the square root. Okay, so 7 minus 3 is 4. The square root of 4 is 2. That is true, right? Okay, so 7 is definitely a solution. But then if I try x equals 12, I get 12 plus the square root of 12 minus 3. Yeah, so 12 minus 3 is 9. The square root of 9 is 3, and that does not equal 9. So this we call an extraneous solution. Yeah, so on the test, if you don't go back and check your solutions, if you count an extraneous solution, you might lose like 1 point. Something like that. Okay, so you see a power on the x that's bigger than 2. We don't have very much in terms of techniques to try to do that. When it's 2, you can use the quadratic formula or factor. But higher than 2, all we can do is like cross our fingers and hope we can factor it, right? So what I see here is I have an x to the 4th and an x cubed. So both of my terms have x's in them. So I can try to factor out some x's. And if I pull out the highest power of x I can, I'd pull out an x cubed. This is like a reverse distribution process. So what I'd be left with when I distribute my x cubed to 2 terms here, I want to make it so that when I distribute the x cubed, I get what I started with, the 5x to the 4th minus 12x cubed. So x times what would give me 5x to the 4th? 5x. And x times what would give me negative 12x cubed? Minus 12. Good. So now I have 2 factors multiplied together. The answer is 0. So either x cubed is 0 or 5x minus 12 is 0. And the only way x cubed is 0 is if x is 0. And 5x minus 12 equals 0 means x equals 12 fifths, or that would be 2.4 if you change it to a decimal. Either of those would be acceptable. So yeah, so this is if you're just looking at this thing, right? That's a 4th degree polynomial, which means there are 4 zeros total. So you find them by setting the polynomial equal to 0 and solving, right? So we've got 1 here and 3 here, right? Because it came from an x cubed, right? Which means x times x times x, which means you get 0 as a solution 3 times. So those are your 4 zeros. If you're just if you're solving an equation like this, you don't have to write multiplicity 3. You can if you want. I'm not going to take anything off. But it's a slightly different question to ask for solutions to this equation than to ask for zeros of a polynomial. So if I ask you to find zeros of the polynomial, yes, you would write this. And if I just give you this equation and tell you to solve it, I just want to know what values of x make it true, and you would say 0 and 2.4. Yeah. But if you wrote multiplicity 3, I would certainly not take anything off. Okay, so this is a rational equation. This one is particularly easy because I could just cross multiply, right? But so when you can't do that, a better thing to do is to multiply both sides by the common denominator, right? So first, I would figure out what my common denominator is, which you would do by like imagining that you had to add all those fractions together. You want them to all have the same denominator. So my common denominator in this case would be x times x minus 4. And then you multiply both sides of the equation by the common denominator. So I'm going to multiply this whole side by x times x minus 4, and this whole side by x times x minus 4. All right, on the left, I have, and these are both over 1, over 1, over 1. Okay. So on the left, I have an x in the numerator and an x in the denominator. This x and this x cancel. So I'm left with 18 times x minus 4, and my denominators are just 1s, so I don't even have to write them. And then on the right, I have an x minus 4 on top and on the bottom, so those cancel, and I'm just left with 10 times x. My denominators are just 1, so I don't even have to write them. And now I have an easy linear equation to solve. Distribute my x, my 18. Okay, so I get 8x equals 72, so x equals 9. So equation to graph. How do I do this? All right. So just like you asked me the other day, how do you take a graph and make an equation? You have a similar first step for how do you take an equation and make it a graph. The first thing you have to do is classify the equation. So we have learned several different kinds of functions about several different kinds of functions this semester. So it could be a line, right? It could be y equals mx plus b. And if it looks like that, you know it looks like a line. It could look like a quadratic, which would be, or like that. It could be a cubic. Or, right, multiplying three factors together to make a cubic. Same with a quadratic. This could also be multiplying two factors together. So that's linear, quadratic, cubic. You could have higher degree polynomial also, which would just be ax to the fourth plus bx cubed plus cx squared plus dx plus e, or 4 factors being multiplied together. Let's see, what else could it be? It could be some transformation of an absolute value, right? What other kinds of functions have we learned about? Exponential. Or logarithmic. Right, some transformation of a log function. Okay, so you have to sort of know the general shape of some of the parent functions. So we kind of call them parent functions. So mx plus b, you have to know that that looks like a line, right? And then figure out what the key components of that line are by using the slope and the y-intercept. Quadratic, you know that looks like a parabola. Right? And you can either use transformations to try to graph it using the parent x squared. That's what I would do, yeah. Same with a cubic, right? A cubic has this general shape like that. And you know the end behavior, you know, you can determine some of its behavior just by looking at its equation. You know, its end behavior, because it's cubic, is going to be one arm up, one arm down. And whether the leading coefficient is positive or negative would mean right arm up or left arm up. Absolute value, that's a parent function that looks like this. And exponentials, right? So for growth, it would look like this. And for decay, it would look like this. So basically, when, oh, and then I have a log function, looks like this. That's the parent function. And then one more, actually, I just thought of. Square root function. And it looks like, starts at 0, 0. And it kind of looks like the log function, except it doesn't go down to infinity. A piecewise is any combination of the parents that I gave you. Yeah. All right. So, oh, rational. Yeah, yeah, yeah. Okay, we got another one. Fraction, right? Some polynomial over another polynomial, and the parents are like 1 over x. You know, so they typically have this shape where they're like two curves separated by an asymptote, right? They're not always, they could be both up here. There could also be, like the one on your quiz also had a down part, right? And then these two had like a center curve. So it has these typical characteristics. All right. So first, classify the equation and get a general idea of the shape of the graph in your head. Okay, so 1, classify equation, and that tells you, you know, sort of a vague idea of the shape, you know, what it's sort of going to look like. And then 2, use stuff from the equation to get more specific characteristics. Use info from the equation. So like with a line, you would use the m and the b. With a parabola, you would use the h and the k to get the vertex. With a polynomial, you might use the zeros. You know, you might take the factors and say, okay, if these are the factors, I know the zeros, and you'd plot x-intercepts to get specific info of the graph, right? So that might be slope, that might be the vertex, that might be the zeros, that might be the asymptotes, right? You can find all these things. If you know what kind of function you're dealing with, you know where to look in its equation for various characteristics. Okay, and then 3, and this is sort of, if 1 and 2 are completely lost to you, right? That's okay. You can always fall back on plot points, right? You can always do this. Plug in a ton of x's, get the y values, and just plot them, right? And you go, oh, this looks like a parabola. And this might take a long time. So if you can do these first 2, you might only have to plot 2 or 3 points to sort of fill out the picture. If the first 2 give you nothing, right, you might have to plot 10 or 20 points to get a good idea of what the graph looks like. 4, yeah, 4 pages of notes. Okay, so this is not a particularly good example for me for you to really see how to solve this because of the duplicate 4s, right? I have a 4 here and a 4 over here. So I'm going to make one of them red and one of them blue, so you can tell which one's which when I'm manipulating it. Okay, so this is a log equation. Log base 4 of 3x plus 7 equals 4. So the way I'm going to get rid of the log is to change this to an equivalent exponential equation. And the base in a log equation and the base in an exponential are the same. So this is base 4. So that red 4 is the base of an exponential, right? Okay. And then inputs and outputs switch because log and exponentials undo each other, right? They're inverses. That means the inputs and outputs switch. So my input into the log was a 3x plus 7. It becomes my output. Oops. It becomes my output of the exponential. And then the output of the log, this 4, becomes the input of the exponential. So this is my base. The red 4 is the base. The blue 4 is the exponent. And the 3x plus 7 is the output. And then I just have to solve this. So 4 to the 4th is 256. Mm, 249 divided by 3. 83.